Hi guys, welcome to Just Coding channel. Recently we're seeing about Leetcode problems, so today also we're going to see one of the Leetcode problem which is asked in Google. So today's problem is called two-sum. As you can see that it's been categorized as easy, okay, and here they mentioned it's been asked in Google. Let's see what the description says. Given an array of integer nums and an integer target, okay, return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. Okay, so what we understand from this statement is, okay, so here you can see we have given an array and we have given a target. Okay, you have to find the two numbers. Okay, when you add up that, you have to get the target value. That's what your goal. Okay, so here you can see 2 and 7, if you add it, we can get the 9, and here 2 and 4, so we have to return the indexes, so we are returning 1 and 2. Here you can see this is one kind of interesting, like let's say 3 comma 3. You can say that why can't I return just 0 comma 0? Okay, but the thing is they clearly mention that you may not use the same element twice, so you cannot use the same element twice. So that's why this could be one element, this could be another element, so you get 0 comma 1. Okay, let's take another example. Okay, let's take an array 3 7 5 7 4. Okay, so my goal is to target to 8, so we know that 3 plus 5. So how do you find it's 3 and 5? Let's say we have very large number of array. In that case, how do you find? Okay, so our usual brute force approach would be go for each number. Let's say if I go with the 0 thing, I'll compare with 3 and 7, 3 and 5, 3 and 7, 3 and 4. Then in next iteration I'll go with 7 and 5, 7 and 7, 7 4. It goes on like 5 7 5 4, then 7 4. This is how we will go. Okay, but here the time complexity will be, since we are iterating with each number. Okay, so our time complexity big of n square. Okay, space complexity, we are not using any additional space, so it's gonna be big of 1. Okay, let's me write a simple pseudocode like how we going to proceed with the brute force approach. Okay, this is what I explained is a brute force approach. Okay, so what I'll do, first I'll write a for loop. It start with 0 to length minus 1. Why? I want to go till 7 only. I don't want to go till 4 because I always need two numbers. Okay, so only if I go till 7, I get the pair number as 4. If I go till 4, I don't have the next number. So it's always 0 to, or you can say, yeah, this is I mean with index, that's why I put length minus 1. Okay, our inner for loop will be, see, as you can see that the next number, okay, if I is 3, j should be the next number of 3. Okay, so it always would be I plus 1, that's the initial. Till length, it can till go the 4th, till the end of the array. Okay, and finally we just check if n of I plus n of j equal to target. If so, just return the I and j. That's it. I and j or j and I, doesn't matter. Okay, this is what our approach would be. Let's write it as a program. Okay, I take C# as a program since that's what I'm comfortable. Okay, I'm just declaring an array for output. We know that it's going to be only two numbers, so I'm declaring as 2. Okay, let's say for int I equal to 0, I less than nums dot length minus 1, I plus plus. For the inner loop, int j equal to, I plus 1, j less than nums dot length j plus plus. As a condition, if nums of I plus nums of j double equal to target. If so, just fill up the array. output of 0 would be I, output of 1 would be J, and we are breaking the looping because we found the answer. Return output. Let's run it. Okay, it's been accepted. As you can see, it's 257 millisecond. Okay, let's submit and see how much time it's overall takes. Okay, it almost like 163 millisecond and beats 43% of the people. Okay, as I said, okay, the time complexity of the program is, since we are using two inner for loop, nested for loop. Okay, so the time complexity is big of n square. Okay, and here they mentioned that, let's go to the description. The follow, can you come up with an algorithm that is less than big of n square? They clearly understood that everybody will go with the big of n square. Okay, but they want the thing lesser than the big of n square. Okay, so it means that we can go with the big of n or big of 1. Anything is possible, whatever the possible case. Okay, let's see how to achieve that. Okay, okay, as I said, okay, this is our, let's take an default example, 2, 7, 11, 15, and our target is 9. Okay, but let's say when you go for the first item, okay, what would be your thought if this is going to be the one of my answer? Okay, so we have to give one array, right? This is our output. If 2 wants to be one of the element, okay, it needs a pair. That pair should be what? 9 minus 2, 7. This is what our pair. Okay, if suppose our target is 8, here it should be 6, right? Okay, so that's what you get. So what we're going to do is we're going to create a one more dictionary. Okay, this is array, we're going to dictionary one more dictionary. Okay, what the dictionary will have is key value pair. So let's say this is key and value. At initially it will be empty, nothing is inside. When I go for the first item, okay, since it's empty, okay, what I want to do is, what is the difference between 9 and 2? Okay, it means 7, and the index of the 2 is 0. Okay, why we are doing is, let's say I'm coming through. When you go for the next number, okay, so the 7 is nothing but 2 is the answer, one part of the answer. I need a 7. If 7 is there, I'll be the answer. Okay, so here what we are trying to put is, I need a 7. Is there somebody is 7? Okay, then we're going to the next item and check whether this 7 is in this collection. It means that it can be paired with 2. Okay, yeah, it's there. Fine, we got it. So now what we'll do, we'll just return this index. So this is 0, 1, 2. What will do? This index plus 7, what's the index? 0. So 0, 1, this is our output. Okay, let's take another example. So since it's going to be very straightforward, okay, let's go with a little bit complex. 2, 4, 7, and 6, 10. Okay, and my target is 8. Same thing, what I'll do, this is my key, this is my value, initially 0, empty, I mean. Okay, when 2 comes, okay, if 2 wants to be the answer, what would be the number? Like 6. The difference is 6, index 0. Then comes 4. If 4 wants to be the answer, it need another 4. Okay, and we are checking the 4 is already there or not. It's not there, so we just add it here and put one index. And 7 is already there in the collection? No. If the 7 wants to be answer, it needed 1 and this 2. And 6 is already there in the collection? Yes, it is there. Okay, then what you do? 0, 1, 2, 3. This 3 index, return it, and 6, what's the index? 0. So 0, 3 will be the answer for this problem. You understand? So what we're going to do is, we're going to create another mapping. In that mapping, in each array item, okay, what is the difference between the item and the target? That we're going to fill it up. Okay, let me alter this program. Okay, what we're going to do, we're going to create a dictionary, int comma integer mapping okay. So I don't want this inner for loop, and I want to go till the last item. If our mapping contains key of nums of I, output of 0 equal to I, output of 1 equal to mapping of nums of I, break. If it's not there, what is the difference value? Difference value is target comma nums of I if this is to avoid the duplicate. Let's say we have two numbers with the same difference. Okay, this is to avoid this case. Let's say I have 2 5. Okay, the difference between the 5 1 5 and the next 5 is same, then I will get this exception, it's already contained. So to avoid that, I'm having this condition. Okay, diff okay mapping diff comma I, so only if it is not there. Okay, return output, let's run it and see if it throws any exception or not. Yeah, it's accepted. As you can see, the runtime is 170. It's greatly reduced. So before that it was around 256 something, now it's been 177. Let's submit and see. Yeah, the time also reduced, 137 millisecond. Earlier it was 163 millisecond, and we also beat 75% of the other users. Okay, for a code walkthrough, here what we are doing is we are just getting the diff between the target and the current element. Okay, whatever the number, let's say when the 2 comes, okay, the target would be 9 and 2, so diff is 7. And if the mapping contains 7, okay, if it's not contained, I'm just adding it here. Okay, and here let's say the next time the 7 comes, checks 7 is already there in the mapping. Yeah, it is there. Okay, then I am filling up with the output array. I is one pair. Okay, the next pair is where is the 7 is there. 7, where is the 7? 7 is was there in the 0th index. So this 0 and this 1 is going to be our output. Okay, and here the space complexity has been increased because we are using a dictionary mapping. It's almost like equal to, in worst case scenario, it may equal to our input size array. So our space complexity is big O of n, and time complexity is reduced to big O of n. It's from n square to n. So that's a achievement, right? Okay, yeah, that's it with this program. So if you have any other suggestion with this program, or you have any other clarification with any other problems in the Leetcode, please comment it out. I'll let you know, guys. I can come up with a new video also with that.